Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture we are going to learn about some challenging and the interesting example to predict the type of hybridization of an atom in molecule. So in the previous lecture we already learned about some interesting example. The link is given in the description box. Kindly watch that video also. Now let us start with the first example. Here I have taken the carbon monoxide molecule. So the molecular formula is CO. So in carbon monoxide, carbon is the central atom. If we consider the electronic configuration of the carbon atom, it will be the 1s2, 2s2 and 2p2. So we know that 2s and 2p atomic orbital contribute to the valence shell, and the number of electron present in that atomic orbital will be the valence electron. So total number of valence electron on this central carbon atom will be equals to 4. Again we find out the total number of atom attached to the central atom. So in the carbon monoxide only one oxygen atom is attached to the central carbon atom. Hence the total number of atom attached to the central atom is equals to 1. So here you have to remember that the one carbon atom use its 2 electron for the formation of a CO bond in carbon monoxide molecule, but there will be the confusion as the carbon monoxide molecule contain the carbon oxygen triple bond. But remember, one bond is a dative bond in which only one atom contribute the 2 electrons. Third bond is formed by the oxygen atom by sharing its 2 electron. Therefore in this molecule you have to remember one important point: the carbon atom uses only 2 electrons of the central carbon atom. Hence the total remaining valence electron in the central carbon atom will be equals to 2. If the total remaining valence electron is equals to 2, then the total number of lone pair of electron will be equals to 1. So again we know that we use a simple formula. Type of hybridization depends upon the number of atom attached to the central atom plus total number of a lone pair of electron on the central atom. So here the total number of atom attached to the central atom, that is to the carbon atom, is only 1, and the number of lone pair of electron in the carbon monoxide molecule is equals to 1. Therefore 1 plus 1, the total number will be equals to 2. If the total number is equals to 2, then the type of hybridization in the carbon monoxide molecule is a sp hybridization. So we are using only 2 atomic orbital and the number also comes to be 2. So this is an interesting and a challenging example. Now again let us discuss the second challenging example. Here I have taken the molecule as an benzene molecule. So I have shown the structure also here. So here we are not going to consider all the carbon atoms. Now to find out the type of hybridization, I am going to consider the carbon number second. You just observe that carbon number second to which the 2 carbon atom and the 1 hydrogen atom is attached. Let's consider the molecular formula of the benzene. As you already know that it is C6H6. Again remember, the central atom in the benzene is a carbon atom, and if we consider the electronic configuration of the carbon atom, it will be 1s2, 2s2 and 2p2. So again the 2s and 2p will contribute to the valence electron. So the total number of valence electron is equals to 4 here. So now let us find out the total number of atom attached to the carbon atom. So here I have considered the carbon number second that I have shown in this diagram. Just observe that the carbon number second is attached to the other carbon atom by single bond, while that carbon atom is again attached to the another carbon atom by the double bond, and it is also attached to the hydrogen atom. So here the total number of atom attached to your central carbon atom is equals to 3. We have to find out the total number of remaining valence electron on that second carbon atom. So here again you can observe that in the diagram, one carbon atom attached by single bond. So the central carbon atom will use 1 electron there. Then it is also attached to the hydrogen atom. So again it will use the 1 electron. So out of 4, 2 electrons is already used. While the other carbon atom attached to the another carbon atom by the double bond. So there it will use the 2 electrons. That means totally the 4 valence electron is used by the second carbon atom in your benzene molecule. Hence, the total remaining valence electron will be equals to 0. If the total remaining valence electron is equals to 0, then the lone pair on the carbon atom in the benzene will be equals to 0. Again, by using a simple formula, we know that type of hybridization depends upon the total number of atom attached to the central atom plus total number of a lone pair of electron on the central atom. So, we know that total number of atom attached is equals to 3, while the total number of lone pair of electron is equals to 0. Therefore, this number will come to be 3. Hence, the type of hybridization of a carbon atom in the benzene molecule is a sp2 hybridization. So, you just again cross verify it. We know that we are using a 1 s atomic orbital and the 2 p atomic orbital. So, total value will be again 3. So, this is a simple challenging example. Here the next challenging example. Here I have taken the xenon trioxide. So, its molecular formula will be the ZeO3. If we consider the xenon trioxide molecule, the central atom will be your Ze, that is the xenon. Electronic configuration for the central xenon atom will be equals to krypton 36, 5s2 and 5p6. So, here again 5s and 5p will contribute to the valence electron. Hence, the total number of a valence electron on the central xenon atom will be equals to 8. I have shown the structure. Total number of atom attached to the central xenon atom is equals to 3, as the 3 oxygen atom attached to the central xenon atom. Now, the total number of a remaining valence electron, here we have to find out. Again, we know that you can observe in the diagram, each oxygen atom attached to the xenon by the double bond. Hence, each oxygen atom will use the 2 valence electron of the central xenon atom. Therefore, the total 6 valence electron will be used by the 3 oxygen atom. Hence, the remaining valence electron on the central xenon atom is equals to 2. Hence, the total number of a lone pair of electron will be equals to 1, as you know that lone pair contain the 2 electron. Hence, total number of lone pair will be equals to 1. Again, use a simple formula, that is type of hybridization depends upon the total number of atom attached to the central atom plus total number of a lone pair of electron on the central atom. So, here you can observe that the total number of atom attached to the central xenon atom is equals to 3, while the total number of lone pair of electron is equals to 1. Therefore, this number comes to be 4, and hence the type of hybridization of a xenon in xenon trioxide is sp3 hybridization. So, here you can again cross verify it. You know that we are using 1 s atomic orbital and the 3p atomic orbital. So, total number will be equals to 4. Hence, this hybridization will be the sp3 hybridization. Next challenging example. Here I have taken the sulfuric acid. The molecular formula of the sulfuric acid will be H2SO4. So, the central atom in the sulfuric acid is the sulfur atom. If we consider the electronic configuration of the sulfur, we know that sulfur atomic number 16. So, its electronic configuration will be 1s2, 2s2, then 2p6, 3s2 and 3p4. So, these 3s and 3p will contribute to the valence electron. Hence, the total number of valence electron of this central sulfur atom is equals to 6. Total number of atom attached to the central sulfur atom is equals to 4. You know that in the sulfuric acid, the sulfur is attached to the 4 oxygen atom directly. Hence, the total number of atom attached to the central sulfur atom is equals to 4. Now, we have to find out the total number of remaining valence electron in the sulfuric acid. So, by observing this diagram, you can see that the 2 oxygen atom in the sulfuric acid attached to the central sulfur atom by the double bond. Hence, the total 4 valence electron will be used by the 2 oxygen atom to form this 2 double bond. That means 1 oxygen atom use the 2 valence electron of your sulfur. Hence, total 4 valence electron is utilized by the 2 oxygen atom which is bonded by the double bond, while the remaining 2 oxygen atom will use the 1 valence electron of the sulfur atom. So, here 2 plus 4 is already utilized. Hence, the remaining valence electron on the sulfur central atom will be equals to 0. If the remaining valence electron is equals to 0, then the total number of lone pair electron will be equals to 0. So again, by using a simple formula, that is, type of hybridization depends upon the total number of atom attached to the central atom plus total number of lone pair of electron on the central atom. So total number of atom attached is equals to 4, while the number of lone pair of electron is 0. Therefore, total number comes to be 4. Hence, the type of hybridization of sulfur in sulfuric acid is sp3 hybridization. So here I have discussed some challenging and the interesting example in the 2 part of this video. So I request you to kindly watch that video, understand that concept. It is very easy. So here I will give you one example and you just find out the type of hybridization of that molecule and comment in the comment section. You have to find out the type of hybridization in oxygen difluoride molecule. So thank you so much for watching this video. See you in my next video.